Okay, yeah. So what we're going to be doing today is putting a point on a function through a transformation when you're given an equation in transformational form. So we're going to start off with just really generic definitions. We got y equals f of x, so some function. And what we're going to do is we're going to take y equals f of x, which is embedded in this transformational form here. So there's your y equals f of x right there. And we're going to talk about what a and k, which are outside of the parentheses, not affecting the x part. Okay, they're affecting the y part of the function. We're going to talk about what those do to a point on the graph. And then we're going to look inside the brackets slash parentheses with the x and talk about how those numbers horizontally affect or horizontally move a point on a function. Okay, so we're going to start with b and h, which are your horizontal transformations, because we're going to affect the x, we're going to affect the graph horizontally with the x component, and then affect the graph vertically with the y component. Okay, so horizontal actions, and I just use an H with a circle to indicate that this is a horizontal action. So our horizontal effects are going to move our x, okay? They're going to move the x component of your ordered pair. So if I have some ordered pair in x comma y, okay, we're going to take b and h are going to affect the x component. A and K are going to affect the Y component. All right, but let's talk about what order we're going to do them. If you have, so we're horizontally affecting, so we're talking about B and H, which number should we, which value should we transform, use, I can say words, which number should we use to transform the X value first or the horizontal component first? It's going to be B. So when we're talking about B, okay, we're going to look at B, and it could do two things here. First, we're going to talk about how it affects by stretching or compressing. So it's going to do what's called a dilation. There's just the major term there, but it could be a dilation in the form of a stretch, or it could be a dilation in form of a compress. And what you're doing either way is to multiply your x term by the reciprocal of b. Okay, so that's really important to remember. Anything that's happening inside the parentheses with that x, you're always going to want to go times, like with the inverse operator. So if it says times 3, then you're going to multiply times 1/3. If it says plus 2, then you're going to subtract 2. Okay, so we're going to work off b first. Okay, so it's going to be a dilation, whether it's a stretch or compression. You're just going to take your x component, multiply it by the reciprocal value. Okay, when we're talking about h, h is a shift or a translation. Wait, let me take it back. Erase. Let's talk about what is it. What if it's a negative b? Okay, then that is a reflection across the y-axis because it's a horizontal reflection. So anything on the right is going to reflect to the left. Anything on the left is going to reflect to the right, left and right. And so that just means you're going to take your x and multiply it times a -1. So it's going to be an opposite x value. All right, and then let me talk about h, which is where I was going. We are going, h means to shift the graph left or right. So these are all horizontal effects. So if it says plus h, we're going to shift to the left. If it says minus h, we're going to shift to the right. So you're basically doing your x component plus or minus h. Basically, you're always just going to go the opposite direction of whatever it says in the parentheses. So if it says, for example, x minus 3, then that means you're going to go 3 to the right because you want it to zero back out. So you need that x to be 3 so you can get it back to 0. Not a very good explanation of that, but that is what that comes from. Okay, so those are your horizontal effects. You can have a B, and that's just a dilation multiplied by the reciprocal. If it's a negative B, it's going to be a reflection across the y-axis, and then if you've got an H, it's going to push the graph left and right. Those are all effects on your X component. Now let's go to our vertical, change color here, our vertical effects. Those are going to move your Y component in your ordered pair, and then here's the order that you're going to be doing that. We're going to start with A. Okay, that's the number out in front. Okay, that is also a dilation, which is a stretch or a compression based upon its factor. And so basically you're going to take your Y value and multiply it times A. That's what you do. You don't have to do opposite. It's gonna, whatever the effect is vertically, whatever it says for A and whatever it says for K, that's exactly what you do to the vertical component, which is your Y component. All right, so A is a stretch or compression. You're going to take your Y times A. If it's a negative A, then you're going to do a vertical reflection or flip across the x-axis. So if you have a point above the x-axis, it's going to reflect below. If you have a point below the x-axis, it's going to reflect above. So that just means you're going to do negative times your y value, or -1 times your y value, or negative A times your y value. That'd be fine as well. All right, and then your K is a shift up or down. And so if it says plus K, you're going up, and if it says minus K, you're going down. Okay, so you have multiplication and you have addition and subtraction. That's what you have there. So we're going to go over to this box over here. And first what we're going to do is just read it, describe how the effect on the given function, and then we're going to put a point on that function through the transformations that we described. So let's start with horizontal here. All right, and so there, this says x minus -2 if we were to put it in the proper format where it says x minus h. Okay, so this is a shift left, right? It says +2. So we have a horizontal shift left 2. So we're just going to take our x value, whatever it is, and subtract 2 from it. And that's the only horizontal action I see in that description there. And then we have a K right here. And so we have a vertical shift. And it says -1. So that's going to be down 1. So that just means we're going to take our Y value and subtract 1, whatever that Y value is. Okay. And so those are the only two numbers that we have in that transformational form of the function. So now we're going to take this point P. So it says if point P is on the graph of the function f, find the corresponding point on the graph of the given function. Okay, so we're going to find what's called the image of the point, or point prime. Okay, so we're going to take our horizontal component 0 and our vertical component 5, and we're going to put them through the transformations. So going back to the top here, we said we were going to shift left 2. So we're going to take 0 and we're going to shift it left 2, right? We're going to subtract 2. Then we're going to take our vertical component 5 and we're going to shift it down 1. So we're going to subtract 1, okay? And so let's just simplify that out. That's at -2. That's left 2. And 4. Okay, so P prime is at -2, 4. Something else you could actually do is just put it on a graph. 0, 5 would be right here, and you can shift that left 2 and then down 1, and you could see the point right there would be at -2, 4, which is another way to go about that. All right, so that was just an example where the function, the transformational form, just had shifts in it. Let's go to one that has some stretches, compressions, okay, and some shifts. So let's take a look at this one. Explain how the graph of the function compares to the graph of y equals f of x, just some random function. So we have y equals 1/3 f of x, f of half of x plus 4. So 1/3 and plus 4, those are your vertical components. And then you have a b term right here. So 1/2 of x, so that's your b term. So you have an a, you have a b, and you have a k. So let's start with the horizontal change, right? That would be b. So that is a horizontal. So we're going to do the reciprocal of b. So that would be times 2. So recip would be times 2. So that's a horizontal stretch. Okay, so we're just going to take our x value times 2. So you're just always going reciprocal of the b term right there. So it's a stretch, not a compression, because it's stretching further apart. Okay, and then let's take a look at vertically. We have our A is 1/3, so that is a vertical compression times 1/3 y. So you're going to take 1/3 of your y value, right? And then you also have a vertical shift because your k is 4, and that's going to take the function or the point and push it up 4. So you're just going to do your y value plus 4. But actually, you're doing 1/3 of your y value, which is coming from there, and then you're adding 4. So you're taking 1/3 of y and then pushing it up 4. Okay, so let's go down here. And now that we've described what's happening, we have a horizontal stretch by doubling the horizontal stretch, then a vertical compression by 1/3, and then a shift up 4. Okay, so let's take our point. If the point P is on the graph of the function f, find the corresponding point or the image of the point, that's P prime, on the graph of the given function. So we're going to take 3, 9, and we're going to put it through the transformation. So 3, 9. That is not what I wanted to do. Let me back that up just a second. Apologies. And we're going to put it through the transformation. So we're going to do horizontally, we're just going to stretch from out 3 to out 6. Okay. And then we're going to take 9, multiply it times 1/3, and then add 4. So 9 times 1/3 is 3, plus 4 is 7. And so that point moved from 3, 9 to 6. So you can see that the 3 doubled to 6. Okay, and 9 was cut in 1/3, and then 1/3 of 9 is 3, and then pushed up 4. Got it? All right. Last one. This one's a stinker because it's got everything going on. It's got stretches, it's got flip reflections, it's got compressions, and it's got shifts. It's got everything. So let's start with taking a look at, so we've got some given function. Let's take a look at what's happening here. So that's b is -2. So it's got a negative, which means it's got a horizontal reflection. It's -2. So we're going to multiply times half to give it a horizontal compression. It also has a shift. It says +1, so that really means left 1. Okay, so let's start with our horizontal transformations. We're going to start with the reflection. So we have a horizontal reflection. So we're going to take our x value times -1. Then, so that's going to go across, again, the y-axis. But we also have a horizontal, because it's 2, we're going to have a horizontal compression. So we're going to be multiplying our x times now -1/2. So to take into account that we had the horizontal reflection, and now we're doing the compression. And then let's go to this last value here. It says +1, so that's going to be a horizontal shift. Left 1. So that means we're going to take our negative half x, which we've already done that, and we're going to shift it left 1. So we're going to do minus 1. So those are all of the horizontal actions on our horizontal component. Now we're going to go outside of the parentheses and look at these three transformations of the function. So we've got vertical changes. So we have a vertical reflection because our a is negative. So that's a vertical reflection. So that's going to be our y value times negative 1. And that's a reflection across the x-axis because from top to bottom or from bottom to top. All right, then you have a vertical, this is 4, so this is a stretch, and that's going to be your y times 4. So you're doing your y value times negative 4 because we're going to consider that we are also doing the negative 1. I guess I could write it out like this and do it one at a time. So we're doing y times negative 1 times 4, right? That's considering everything instead of putting it all together. Last thing, we have over here our k, which is plus 1. So that's a vertical shift up 1. All right, so we're going to take our y that we had a horizontal or vertical reflection on, and then a vertical stretch on, and then we're going to push it up 1. Okay, so here we go. If our point P is on the graph of the function f, find the corresponding point on the graph of the given function. So we're looking for the image of the function through a transformation, or an image of the point. So we're starting with the point 2, 4. And so we're going to take our horizontal component 2. We're going to multiply it times negative 1/2, and then subtract 1. So there's our reflection, there's our compression, and there's our shift left 1. Okay, so let's do that math. That would be, excuse me, negative 1 minus 1. So that would be negative 2. And then 4, which is our horizontal starting point, or vertical starting point, we're going to multiply that times negative 4 and then add 1. So that's going to be negative 16 plus 1, negative 15. So the point 2, 4, when put through the transformations, the image of that point will be at negative 2, negative 15. Okay, so that's kind of abstract. That's kind of weird, just moving a point. So let's put it all together by taking a look at the function f of x equals x squared. Okay, so let's just look at the parent function of a quadratic, and let's transform it by moving 5 of its points, given the transformational form of y equals negative 2 f of 3x plus 4. Okay, so we're going to start with just the parent function here. So we'll just do negative 2. So we're going up to this function right here. If we plug in a negative 2 squared is positive 4. Okay, so negative 2, 4, negative 1 squared is 1, so negative 1, 1, 0 squared is 0, right? 1 squared is 1, and then 2 squared is 4. So these are the 5 points that we would typically graph if we were doing a transformation of a quadratic. We would take those 5 points and put them through the transformation, the parent function. All right, now let's see what we have going on here in our transformational form. So inside the parentheses, our b is 3. So that means we're going to take our horizontally, we're going to take our, this is a horizontal compression, right? Because we have to use the reciprocal. So we're going to do our x values times 1/3. Okay, so that's our only horizontal thing that's happening. Now let's go outside the parentheses here, and we've got all of the vertical transformations here. So vertically, it's a negative 2 on our A, that's negative 2. So we're going to do a vertical reflection, right, times negative 1. And then it's a vertical stretch because it's 2. So we're going to stretch times 2. So that just means we're doing our y value. We'll do those at the same time. We'll take our y value, multiply it times -2, because that's what it says to do. -2 times our f of x. That's what it says. Okay, and then we also have a vertical, we have our k value here, our vertical shift, and this is just going to push our y value up 4. So we're basically doing -2 times our y value and then plus 4. There's our up 4. Okay, so let's just take all of these points. So let's take the point -2, 4, and put it through the transformations. So horizontally, we're compressing -2 by 1/3, and then taking 4 and multiplying it times -2, and then adding 4. So that's going to take that point to -2/3, and then let's see, -8 plus 4 is -4. So I'm going to go over -1/3, -2/3, and then down 4. 1, 2, 3, 4. Okay, so there's that point. So this point has now been transformed to that location. Right, let's do the same thing with the others. So let's take the point -1, 1, and do the same thing. So we're taking -1, 1 times 1/3, and then times -2 plus 4 on the y value there, and we get the point. I don't know why I keep color coding, but I am, and it just is what it is. So that's going to be at -1/3, and then that's -2 plus 4. So that would be -2 plus 4, 2. Right? -2 plus 4, 2. All right, so we're going to go over 1/3 and up 2. That looks good. All right, now let's take the point 0, 0, which is our vertex here, and put it through the transformation. So 0 times 1/3, and then 0 times -2 plus 4, and that's going to take us to 0, 4. All right, and so that gets us our point right here. 0, 4. All right, and then we just have to go to the other 2 points here. So that just means that my vertex moved up to 0, 4. All right, now we have the point 1, 1, and we're going to put it through the transformation. 1/3, and then -2 plus 4, and that's going to get us to the point 1/3, and then -2 plus 4 is 2. So 1/3 up 2. All right, there we go. And then we have the last one to do here. We're going to take the point 2, 4, multiply 2 times 1/3, and 4 times -2 plus 4. All right, and so that would be the point 2/3, and then 8 plus 4, -8, excuse me, -8 plus 4 is -4. So that would be 2/3 down 4. All right, and so here would be our transformed function. All right, so I'm wondering if you can see the horizontal compression, right? If you were to like imagine that you were pressing in on this function, you could see that the y values got much closer together. And then you can also see that there's a vertical stretch, because originally, if you look at this point, you were going up 1 and then up 3 to get from the vertex. You were going up 1 and then up 3. And then when you go to the next one, you're going down instead of up because it's got the vertical, but then it was down 2, and then it was down, what's that, 6? And then down 2, and then down 6. So you can also see the vertical stretch happening. And then instead of going up, it's going down. So you can see the vertical reflection, and then the shift up 4 because your vertex moved up 4. So that's putting the whole function, f of x equals x squared, just a quadratic, through the transformations by moving a couple points. So hopefully soon we can just look at a parent function and move all of its points pretty quickly if we practice moving just a couple points. All right, so that's all I have for you today. I hope that made sense. Come back and see me at my desk if you have questions. Have a great day.